Welcome to part 4 of 5 of the 2018 Storm Spotter training from the National Weather Service in Milwaukee. I'm meteorologist Ben Herzog and I'll be guiding you through this training. Here we'll be talking about observing severe weather. So, what severe weather types need to be reported? In general, we're looking for reports of hail, the diameter of the largest stones, winds, estimated or measured wind speed and damage, flooding. Rain measurements are great, and we're also looking for reports of washed out roads, and finally tornadoes. The tornado, the funnel cloud, wall clouds, damage. We'll get into all these things and more with greater detail as we go forward. Hail is the easiest type of severe weather to report. All you have to do is measure the diameter of the largest hailstone using a ruler or just compare it to other objects. The size of a quarter, which is 1 inch, is considered severe. Here's an example of the types of objects you can compare hailstones to, and you see as we get to quarter-sized hail, or 1 inch, that's the point at which we are concerned with severe hail. That brings us to damaging winds, the most common type of severe weather in southern Wisconsin. Unfortunately, it's also one of the more difficult types of severe weather to get accurate reports on because in general people have to estimate. I don't know about you, but I don't really carry an anemometer around to measure the wind speed. And unfortunately, people really do tend to overestimate wind gusts. You can use things like tree branches or limbs or entire trees being uprooted, but most people just say trees down, and that in and of itself is not terribly descriptive. Can you tell us some things about the tree? Was it rotted out? Is it just a few limbs that are off? Is the whole thing knocked over? Be as descriptive as possible here. So here's a great chart to use to help you estimate wind speed. When you start seeing whole trees in motion, a lot of people will see that and say, oh my gosh, this has got to be at least 60 mile an hour wind speeds. Well, if nothing's breaking off of the tree, in all likelihood, you're probably in the 30 to 40 mile an hour range. Twigs or small branches can start breaking off between 40 and 50 miles an hour, and once branches and smaller limbs start breaking off, that's when you're in the 50 to 58 miles an hour range, and that's generally where we want to start hearing about your reports of strong winds. As you start seeing visible structural damage or large branches being broken off of trees, that's when you're 58 to 75 miles an hour, and that's when we're in excess of severe winds. And as you get over 75 miles an hour, that's when you start to see the loss of roofing materials or whole roofs being ripped off. Trees may become uprooted or snapped at trunks. So let's try and estimate some wind speeds. How fast do you think the winds are going here? Does this look like severe winds to you? Well, we definitely have whole trees in motion, and you're maybe seeing some twigs or small branches flying through the air, but overall it's not really going very fast here, probably 30, maybe 50 miles an hour. Unfortunately, this is frequently reported to us as estimated 60 to 70 mile an hour gusts, just because this is something people don't see very often. So if we get that report, we're going to ask, what kind of damage is there? If there's no damage, we're going to question that report. And so don't use the wind speeds listed in the warning as your guide. Really use these estimates to help you out. So here's another example. How fast do you think the winds are going here? Certainly faster than the last example that we saw. In fact, you see that the flag about to fly off of that flagpole. You really don't see too much debris here, but I bet if you went out there once this rain ended, you'd see quite a bit of tree branches and things like that on the ground. In all likelihood, you're looking at severe winds here, somewhere between probably 50 up to maybe 75 miles an hour. And one last example. How fast do you think the winds are going here? Well, pretty clearly these are pretty serious winds. Look at all the debris coming off the top of that building. This is some very serious winds, probably over 75 miles an hour. Certainly something that we'd want to know about. How about shelf clouds? These clouds are sometimes associated with strong winds, but oftentimes they happen with no winds at all. They're pretty, but you really don't need to report them to the National Weather Service because that relationship between winds and shelf clouds is just not very strong. How about flooding? Well, if you've got rainfall measurements from your location, we're happy to have that. If you can provide hourly measurements, that's great. If you can provide 24 hourly measurements, that's fine too. That helps us rate our estimates. Additionally, if you can give us reports of washed out roads as you come across them, that's great, but don't go out and search for them. Take a look at the image in the bottom center portion of the screen. Can you imagine driving down this road at night trying to find washed out roads, and all of a sudden you come across this with no lights on it? There's a good chance you're driving into that trench formed by the flash flooding, and you're going to be in a pretty dangerous situation at that point. Finally, that brings us to tornadoes. While reporting of wind damage, hail, and flash flooding are important for the National Weather Service to know of as soon as possible, spotters really add the most value with their spotting of tornado formation and prompt reporting directly to the National Weather Service. So when we talk about tornadoes, first we'll go into a few precursors to tornadoes, wall clouds and funnel clouds. We tend to get lots of questionable funnel cloud reports. We'll see some examples up here of some what we call scary looking clouds where it may look like it's kind of coming down from the storm, but it's not actually doing very much. What's really important to note is the funnel in contact with the ground? If it is, then yes, you have a tornado. If it's not on the ground, then it's just a funnel cloud. Keep in mind that cloud movement does not necessarily mean rotation. Look at what's happening along the ground. Is there any debris being kicked up? Are there power flashes? Is there any damage occurring? If there is, those are some telltale signs of tornadoes. So we mentioned wall cloud as being a precursor to a tornado, and what we see here are two pictures of wall clouds in southern Wisconsin. In general, a wall cloud is an isolated lowering near the rear of the storm, and what this is the updraft area of the storm. So this is where air is being sucked in and up into the storm. Some key features to let you know if these wall clouds may turn into a tornado is this a persistent feature? Is it lasting for a long time, or is it fleeting, just kind of there and then it's gone again? Is it rotating? Again, keep in mind that rotation and movement are not the same thing, but stand and look at the wall cloud. If you see some portions of the cloud toward the front going in one direction and portions in the back going a different direction, well, that's most certainly rotation, and that's something that the National Weather Service does want to know about. A couple of things to note. Again, movement does not equal rotation, and having a wall cloud does not mean that a tornado will form. However, it does mean that the storm is at least starting to become capable of maybe producing a tornado, and it's something that we definitely want to know about. Here's a time lapse of a wall cloud in Edgerton, Wisconsin in June of 2017. It's a little bit difficult to see, but if you look kind of on the front side of the storm and the back side of the storm, you do notice that the cloud does appear to be rotating somewhat, and this is indeed an example of a rotating wall cloud. The next step beyond a wall cloud is a funnel cloud. What this is rotation at the base of the thunderstorm, still in the updraft area, so air is still being sucked in and up into the storm. You're looking for similar things here as you are with wall clouds. Is this a persistent feature? Is it actually rotating, or is it just something extending down from the cloud that's just sort of moving? Obviously, funnel clouds are reportable to the National Weather Service, and it may or may not trigger a tornado warning. There are some times in the fall months where we get things called cold air funnels that have very low chance of actually reaching the ground, and meteorologists at the National Weather Service have a good understanding of the types of days that tend to produce those types of funnels. I mentioned that there are a lot of things that can tend to trick people that they think are funnel clouds but actually aren't. Here's one example in the center portion of the screen. You definitely have got some raggedy cloud kind of hanging down from the bottom of the storm, but nothing is rotating, nothing is persistent, nothing's even coming close to the ground. This is certainly not a funnel cloud. Here's another example of something that's not a funnel cloud. This is actually what we call a Scud Cloud. Notice how, sure, this cloud is pointing straight down to the ground, but there's really no rotation with that feature down there. And the connection to the cloud is really pretty ragged at best. And so this is a classic example of a Scud Cloud that may trick a lot of people into making them think it's a funnel cloud. So finally, that brings us to tornadoes. Keep in mind they don't all look alike. Here's a tornado from Madison in October of 2017 going down a street, and it almost looks translucent as it goes down the road. It's very hard to see. So it's certainly not your classic idea of what a tornado looks like. So you need to be prepared for all things while you're out there. So here's another view of that same tornado from an individual actually about to drive through it. I don't think this person has any idea what they're about to drive through until it passes right in front of them here. So keep in mind, not every tornado is going to have that classic look to it. It may look like something you're not expecting at all. So just please be aware of that as you're out there. When it comes to looking for tornadoes, make sure you watch for debris. Take, for example, this image on the right. You see the funnel cloud coming down and then it kind of disappears. So you think, oh, that's a funnel cloud, not a tornado. I'm not that worried about it. However, if you look down at the ground where the circle is, you actually see that that funnel, while invisible, is actually picking up quite a bit of debris on the ground, and that's a signature that the tornado is indeed on the ground. A couple of other things to be aware of is your tornado rain wrap, like the Chautauqua tornado was. And then watch out for lookalikes like Virga or Scud. Again, tornadoes are where spotters can really make a difference in saving people's lives, and that's because people react to reports of tornadoes. Now, when it comes to nighttime tornadoes, there's several more things to keep in mind. Nighttime tornadoes can be pretty dangerous because this is pretty similar to what your view looks like. You're really relying on lightning to see anything, and it's only right there does this person actually see the tornado that's forming. So you must be very careful while you're out there. Again, night spotting can be very dangerous. It's really important that you're experienced while you're out there, and radar support is a must. Because your situational awareness is so low because it's dark, you've got to know where you're at with relation to the storms, and a radar is a great way to do that. So how do you spot a tornado at night? Well, again, you're reliant on lightning. You're reliant on things like transformers or power lines being hit by the tornado, exploding, and then illuminating the tornado. You may also hear a roaring sound, but you've got a question, is that the tornado I hear, or is that just high winds? Because winds do tend to be pretty strong around storms that are producing tornadoes. Finally, that brings us to Gustnadoes. These are small whirlwinds which form as an eddy in thunderstorm outflows. They don't connect with any cloud base or rotation, and these are not a tornado. However, these can cause some damage, and so we're happy to get reports about them. And then here's another example of a Gustnado from June of 2017. Many reports of people seeing a tornado at the Kettle Moraine Lake, though, and you notice in this image, there's really not anything connecting with the bottom of the cloud. However, you see that there was some damage, and so this is certainly something that the National Weather Service would like to know about. And that brings us to the end of the Observe section, and up next is the final and most important section, Communicate.